The first assignment is some stuff about using NumPy and using pandas and some other stuff. So I want to get started maybe talking about that and see if you guys have any questions on those sorts of things. So I have my camera here. So like I said in that announcement, I am trying to record this so that I can post these after the fact as well. So hopefully I'll get this set up smoother for the next time. So so yeah, if you look at that video, let me just mention a few things from that. I'll try not to spend too much time on that. I don't know if you guys are all set up yet or not. I'm going to go ahead and get my Visual Studio Code going here. So kind of a reminder that keep losing all my stuff here. That let's start with let me start with these things first. So if you're still working on getting stuff set up, as I kind of said in that video, this is stuff I wanted to do last Thursday, but you need 3 tools. You need to have the Docker desktop running on your system. You need to have a GitHub account and the Git tools installed. You need to have VS Code and the dev containers extension. Okay? So a couple of things I mentioned in that video. You do have to have the Docker desktop running, and it needs to show that the engine is running on the lower left of that thing. So if you don't have that working, you've got some debugging or something to figure out to get your Docker desktop up and running. Okay? So the most common problems, Mac people have been having, not been having as many problems lately with Docker or getting it working. So for Windows, do check your BIOS. So if Docker isn't starting for you, you might have to get into your BIOS, find your CPU settings, and look for the virtualization. Make certain that's enabled. That's a common reason Docker doesn't work on Windows. The other is Docker is supposed to, you should use the WSL, so you should leave that checked when you first install Docker. But it's supposed to set it up, but it doesn't seem to always do that on people's systems. So you need to check that you've got WSL updated and installed on your system and running. Okay? So usually if people get both of those issues on Windows, they can get Docker running. And if you're on Mac, usually most people are getting Docker on their first try and be able to get it up and running and stuff. So I show some things here. I don't know if I'll go over this all again. You can check the window. But if you still having problems with your secure shell key, let me know. Don't skip these steps that are shown here. So you do need to configure your username and email once you have the Git installed. Use your name as it appears in our grade book for the class. That'll help me in various ways so that I won't have to search around. And your email should be the same as the primary email on your GitHub account. So we get into my GitHub account here and just show that real quickly. Probably should move this. I'm not going to be able to see this here. Move this down a little bit. So I usually, when you're in your GitHub account, I usually on the upper right-hand side, there's lots of stuff you can get access to, including your settings. So you need to check your email settings and make certain that whatever your primary email is, that's what you need to set up for the Git configuration for the user.email global configuration. And if you can, use your Leo email address. So hopefully all you guys are past this step already, but I would prefer when you create your GitHub account, if you don't have an existing GitHub account, that you do use your Leo email as a primary. Although it's okay if you already done past that step, if you have a different email address. And then a couple of things on here that I've had people have problems with. When you generate your key, you should go ahead and select the default name of the file. So we'll create a file in this .ssh directory, 2 files actually. The public PV has the public portion of the key pair, and the one without an extension is the private portion of the key pair. Some environments, some setups are now generating ED25519 keys by default. So just pay attention to that. So you might have to open up you might have to find the ED25519 file. So yeah, question.
So whenever you pull or comment any changes in the repository, does Git ask for username or email?
No. So if you get the secure shell key authentication set up, it will use the secure shell key to authenticate. These configure part of the authentication, part of creating a commit, it will use this information whenever it creates a commit to fill in certain stuff. So yeah, you shouldn't have to be typing in your email and password whenever you create a commit or push a commit once you get this stuff set up. So like I showed, if you watched that video, let me bring up a terminal here real quickly. So when I won't generate that key on here, but you can just navigate to your file system to open that key if you need to get it copied, if you haven't copied it to your GitHub account yet, or if you're on a terminal, it's really tough to see, isn't it? If you're on a terminal, you can use the cat command, or if you're on Windows, you use the type command equivalently, so type or cat, to display the contents of that file. So it should be from your home directory. It should be in a directory called .ssh, and then you want the public portion of the key, right? So how would you get access to that? So you can either use your file explorer or file browser to open that file in like an editor, or type or cat it out from your command line, but you need to copy and paste that file. So, and that was why I mentioned that, you do have to kind of pay attention when you generate it. It might be in the ED25519 file instead of the RSA, depending on the default for the Git that you install. So either protocol for the key should work. So this is an example of an RSA key. Right? So what I would do if I wanted to add this key in here is I would select that, just go ahead and copy it, and then go to my GitHub account. So again, on your settings is another area where you can add and manage your SSH keys and other stuff. So here I've already got, this is actually my RSA key on my on my laptop system here, but if I wanted to add this, I would just do a new SSH key and paste that public portion of the key in there and give it a title. Okay. So if you haven't done that stuff yet, you need to have that done. I'm not going to actually save that key because I've already got it on here. And then finally, talking about keys here, also don't skip this step here. So do authenticate your key from the command line before you try and clone something from GitHub. So if you skip this step, it will ask, so the first time you connect to a site like GitHub, you have to verify to Secure Shell that, yeah, this really is the correct site, right? And this adds that site into your list of known hosts. So if you don't do this from the command line, if you try and do a git command in VS Code for the first time, it prompts this somewhere, but you might not see it. So that confuses people a lot. So, and also you can just check, at any time you can open a terminal and check if your key is correctly authenticating. So, so for example, I'll just check my key right here by doing SSH to git@github.com to make certain that I've got this key copied to my GitHub account as a valid key I can log in with. All right. So, so if you don't see that it successfully authenticates, something wrong. You shouldn't go on to the next step until you've got a key successfully created into GitHub, your GitHub account, and it's successfully authenticated from the command line. All right. So, I didn't see and again, the first time you do it, so I've already added GitHub to my list of known hosts. But the first time it does it, if you're prompted, you should say yes. This is a known host, and go ahead and add it into my list of known hosts, and then get your authentication. And then the third thing is to have VS Code installed, and to get started, you have to have this dev container extension. Okay, so I've got my VS Code installed and running on my local system here. I've already got the dev containers installed in my list of extensions. So on the left-hand side of VS Code is how you access some of the main functionality of VS Code, including like your file browser in VS Code. This is where you do your Git stuff in the source control section. There's a debugger that we probably won't use for this class. And extensions are how you add in capabilities to VS Code to do projects in different languages. So you can add in extensions for C++ development or Python development or stuff like that. But to get started, all you use is dev containers. If you don't have this installed, you can just search for dev container. All right. We don't need the remote development. These are related. These are doing the same thing, but this does VS Code on like a remote server through SSH. And this does VS Code inside of a container, like a Docker container running on your local system. But yeah, you need the dev. It doesn't hurt if you install other extensions, but you need the dev containers, right? So just search for that, select it, and install it if you don't have it installed already. Right. So if you get that far, you're ready to actually work on the stuff. So I hope, well, we'll see. I hope most people, if you haven't got that far by the end of the day today, let me know. We need to get you up and going, have a good environment. So at this point, we can do things to use the repositories of the class resources and also to like work on the assignments for the class. Okay, so that's the main thing I wanted to kind of demonstrate today. So let's go ahead and show that. So I probably already have, let me remove some stuff so I can show this kind of from scratch. So I probably already have my class resources and assignment 1 repositories here. I'll just go ahead and delete those. So it doesn't help if you're working with Git. It doesn't hurt if you're working with Git. You know, as long as I've got stuff on GitHub, I can always reclone it and re-pull it down. So, but of course, if I've made some local modifications, you wouldn't want to delete those until you make a commit and push them back up here. But let me go ahead and delete these so I can kind of show you from scratch here. And what else should I do? Oh, I know. Well, so so the main thing that you should have been working on kind of last week, and let's jump to the second unit or the second week. I mean, one of the resources that I give are notebooks. So these are referring to notebooks, lecture notebooks that I've created inside of the class resources that you can use and run. So hopefully these will be what you would be enough in order to do the assignments and things for the class, along with the readings from our hands-on machine learning. Okay, there's other resources that you can use, but I kind of intend you guys to use these lecture notebooks. So those class resources, if you go to the additional resources, there's a link to various things, the playlist and stuff. But the top one on this section is to the repository that has all these lecture notebooks for the class here. So if you open that up, so I own this repository, so you can't actually clone this using your SSH key. So when we do assignments, you'll want to clone stuff with your SSH key because that allows you to authenticate and to create commits and push them back so I can see them and grade them. Okay? But for this repository for the class resources, you don't have access to do that. So you have to clone it using the HTTP key. Okay? So this allows you to download a copy of all the files, and you have the files locally, so you can run the notebooks and modify the code and stuff. You just can't push it back up and make changes to my global repository, right? So, but to get started for a repository and you basically start by finding the URL you want to clone and copying it, like I'm going to do here. So I'll just copy that URL. And in VS Code, the way I normally do, there's multiple ways you can do this, but I usually use the source control. So for all things Git or related to a revision control system, you can use that area up there, and you can, in this case, we're going to clone our repository, and you just paste your URL of a Git repository you want to clone. But you should use the first one, clone from URL. The clone from GitHub is something slightly different, so we don't really want to do that right now. We just want to give it a particular URL and clone, that repository using that. In this case, using the HTTP URL. All right. whenever you clone a repository, you have to select a location on your host machine where the files are going to actually be downloaded into and where they reside, okay? So it's good to know the location where that is, because you can actually just go and edit those files directly and do whatever you want with them. So I always recommend people in their home directory, maybe make a special directory. I always have a directory called repos. You can do whatever you want. I usually have lots of repositories, so I'll even have subdirectories in there. So I usually put all of my repositories for particular classes that I'm doing in a subdirectory under repos for that class. So I'm going to select that as the directory. So this will just clone, download all the files for the class resource down into this directory here if we select that as our repository destination. Okay. So if you're not familiar with VS Code, the way it works, the way you work on a project in VS Code is you open up a folder, and the folder acts as the root of the project. So all the files in that folder and all the subdirectories in that file are going to be the root of what Visual Studio Code considers the current open folder, or the current open project that you're working on. So after you clone a repository, you basically want to go ahead and open that folder as the current project that we're working on. All right. So at this point, we're going to test whether you've got Docker working or not. So all of the repositories that we work on in this class will have this special dev container subdirectory in it. And if your Docker desktop is running, and if you have the dev containers extension installed, you should get that pop-up. It went away, but you should get the pop-up offering to reopen the container, the folder in a container. Okay. If you get that, that probably means your Docker is working and you're good to go. And you can go ahead and hit that button. If you miss the opportunity, or if you don't see that, you can always reopen a folder in a container. So by installing the dev containers extension, you'll have a new capability on the left-hand side. So this is supplied by the dev containers. It's called the Remote Explorer because it's also for remote dev containers as well. But this allows you to manage containers or remote connections on your system, stop and start containers and things like that. So I usually, if I miss that opportunity to push that button, or if it doesn't appear, I just go to my Remote Explorer. And I sometimes you'll see it different way. So for me, actually, I want to delete these. So these are I've done this previously. I'm going to get rid of my assignment container that I had on here before, and the class resources container I had on here before. So yeah, when you first do that, if you don't have any containers, it'll probably look like this. So I usually. If you have some containers, you can hit the plus button to open the current folder in the container. But basically what you want to try to do is reopen our folder, but open it up so it's running in the development container. All right? So let's try that and see if it works. So this will depend on, so here I just need to select the folder. I have to tell it which folder I want to open inside of a container if I'm doing it this way. So like I showed you, I downloaded it to my repos, CSci 574 class resources. So that's the folder I want to reopen inside of a Docker dev. So open that up. So if you haven't gotten that far, if you've never done that step before, I'm going to show the log of what Docker is doing here. So if your Docker isn't working or you don't have the extension installed, it might fail. You might not be able to open up. So you have to go back and figure out why your Docker desktop engine isn't running or what's wrong. But if it's working, it might take some time to do that. So mine is already up here. But the very first time I did this, it had to download a bunch of images so that Docker can create the container, and from those images it creates a container. Once it has the container booted up, it installs. So in this case, everything running in this container, it'll have all the stuff that you need to do the assignments and work on the stuff for this class. So it has the most recent version of Python installed. It has the NumPy, the SciPy, the scikit-learn. So it has all the scientific libraries that we'll talk about is running in this container. I mean, you can look at those if you want to. So, for example, if I open up a terminal now, I should point out probably didn't show this in the video, but in the lower left-hand corner are various status things that are good to become familiar with when you're doing stuff in VS Code. So on the lower left, that is an indication that I'm actually running in a Docker container. You can also tell, again, if you go back to your Remote Explorer, you should see that you've got the container, and the green check mark means that that one is currently running. So I'm developing inside the container. So what's that mean? It's like actually having a virtual machine. So if I open up a new terminal while I'm running a container, this is running inside of a Linux virtual machine. It's running in a Docker container here. All right. So even if you're on Windows or Mac, inside of here, it's a Ubuntu operating system. So we can see which OS it is if we cat out it's got its own file system that's internal to the container, etc. OS release. It's a Debian. It's actually just a Debian bookworm. Yeah, I think that's the most recent Debian version. This folder that you start off in the terminal is actually mounted from your host system. So you'll see that these files that we have in the container, we've got a data subdirectory, a docs, a figures, a lectures. These are all shared from the host system into the container here, right? So you can see these same files on your host system if you if you open up a file browser in your host system and navigate to that directory that was cloned or that was downloaded. Right. So if I look in the class resources, I will see these files here, these subdirectories. So we've got a notebook subdirectory, a source, a lecture subdirectory, data and docs. We've got like a README and a NoHub. If I create a file here, so if I if I create a new folder, and so again, I'm creating this on my host system, but I just added a new folder into my class resources directory here. But you'll know, again, I'm just trying to emphasize that these are mounted, right? So this is the same. These files are the same file system. So if we do a directory system on here, anything you do on the host system, you'll see those. It's the same file. So I've got that test folder now here inside of my container. So let me know if you have questions or if I'm going too fast. If you want me to get into something that you see that you need to talk about. So anyway, to get back to this, the main way that I normally work on IPython notebooks. So if you look in here or in your file explorer on your host system, you'll see that there's a bunch of notebooks. So these are the lecture notebooks that I refer to in each unit for our class, right? So for this first week, there was 3 notebooks on Python and data structures in Python. This week you should be kind of looking at NumPy and Matplotlib and Pandas, right? So the other thing so I should have shown here, so when you first start the class resources container or any of your assignment containers, you'll get a message like this. So we actually, inside of the container, we actually run a Jupyter Lab server that gets exported to a port that you can see on your host system. So this port 8888, right? So that means that you can open up a Jupyter Lab server in your normal browser, whatever your default browser is on your system, and work with those notebooks. That's how I normally work. Personally, that's how I normally work with IPython notebooks in a Jupyter Lab server. All right. So what Jupyter Lab servers do now currently is you have to open up this nohup.out file. Let me close this off here. The nohup.out is the output from running the Jupyter Lab server. So the reason why you need this is because nowadays the Jupyter Lab server will generate this long random token, which acts as like a one-time password. So you actually need this to log into your Jupyter Lab server. I mean, you could directly open up So if I just went to my browser on my host system and open up HTTPS colon 127.0.0.1 colon 8888. Okay, so that Jupyter Lab server, you can see that is running on port, it's exposed on port 8888, and the 127.0.0.1 is a special IP that needs my host machine or my local machine. Okay, so if you open that up, you'll get access, hopefully, to your Jupyter Lab server. Do I need to just use HTTP? Oh, just HTTP. I guess it's not served over HTTPS. Oops. There it is. So, but you'll need to type in that token there in order to get in doing this, right? So if you want to, you can just copy in the token. But what I normally do, I don't know if there's a better way to do this, but I normally just control click. So VS Code allows you to follow a link like this by control clicking on it. Any of these should work, I think, but I always just use the 127.0.0.1. So this is like an IPv4 address. This is like the IPv6 address, and this is a way to get it from your local file system. But if I control click on this, we should be able to get in, and it will authenticate with that token, right? So we're actually logged in now into the Jupyter Lab server that's running, and we're able to access all the notebooks and run stuff, okay? So for example, all the lecture notebooks that I showed, they're here in the lecture subdirectory. So, if you haven't looked at, so one of the things you should have been doing the previous week is familiarizing yourself with the basics of Python. So this goes over some of the basics of, just operators, values and types, writing simple functions, that kind of stuff. So, you can always rerun all the cells in the notebook. I use this capability a lot. So this little double fast forward arrow is really to restart the kernel and rerun all the cells. So I'll just go ahead and do that just to show you that, this kernel, this is actually running inside the container. So this Python kernel is running inside of that Docker container, and now all those cells, all that Python code is actually being run in that Linux Debian environment inside of the container. And again, it has all of the libraries. So for example, there's another notebook over in the notebooks subdirectory with all the Python versions. So if you run this notebook, you can see that these are the main libraries we're going to be using for this class. So NumPy, scikit-learn, matplotlib, pandas will be what we'll mostly be using. So, if you're not using this development environment that I asked you that's set up for inside a container, you could just install a Python distribution like Anaconda directly on your system. If you have problems, that's fine, but it would be up to you to make certain that you match the versions and stuff. So if you have problems on the assignments because of a mismatched version of the library or something, that would kind of be on you to figure out or to get the exact same matching environment, right? So these containers are meant to make it a little bit easier for you, so you don't have to worry about that. If you are using the containers, you have exactly the versions I'm expecting for the assignments when I do the grading and I run the tests and stuff for your assignments. All right. So that's the class resources. And if I have time, So let's. I also just wanted to show getting started with the assignment one. And today and Thursday, I'll talk more about the details of the actual 4 tasks you're supposed to be doing for the assignment one. Let's do it at the end of this week here. So when you start an assignment, so for like our assignment one. Normally, when you start an assignment, there should be an area, a sub-unit for each one of the assignments. If you look in there, there'll be what's known as an invitation link for a GitHub Classroom. So if you click on there, that's how you get started on the assignment. And normally what will first happen, if you haven't done that before, is you'll get a list of the students in the class. You get to associate your GitHub account. So I'm logged into my GitHub account. So you should select your correct name from the student grade book so it gets linked to your GitHub account. You didn't see that because I already did that step before. And then you have to accept the assignment. And then once you do that, basically what this does is it creates a repository for you that's owned by this organization that I created. But you're given read-write access to it. So you're given SSH access to it so you can create commits and push it to there so that I can see your assignment work and grade it. Okay? So you can, after you accept the assignment, you can click on that link to get to your repository. If you close that off, you can just click that link to accept the assignment. Another way, the way I normally get back to a repository like this, if I close it, is I just go to my GitHub account, and another thing you can do on that right-hand side is you can look at your repositories and this other stuff. So you won't see it in your repositories because, again, it's owned by, my organization actually owns it. You only have access to it. So to find that repository, you'd have to look into your organizations. So by clicking on that GitHub Classroom, you'll find that you've been added to an organization. You know, if you haven't done this before, you probably only have one organization here, but you should be a member of the organization 574 ML Spring 2025. Right. And then if you go in there and look at your repositories in this organization, I'm going to see everybody's repository since I'm an administrator, but you'll only see the repositories you've created. And I'm sorry, I'm giving away. I see, you know, some people have already accepted the assignment one, quite a few people. But yeah, for you guys, you should only see your assignment one, and you know, when you work on assignment 2, 3, you should only have the actual assignments that were created for you that you have access to as a member of this organization here. But anyway, you can get back to your repository that way through the organizations in GitHub. And then from there, though, so once you have your repository, we'll do a similar step that we did before. We're going to clone the repository, but like I already discussed, we want to clone it using our SSH key. So this will be the first time that we test that your SSH key is working in VS Code to clone repositories here. All right. So we'll copy the SSH key this time for our assignment 1. And go back to VS Code here. So I'm still running my class resources. I don't recommend running 2 or more containers at a time in VS Code. So normally what I do is I just go ahead and stop this container. So if you could do a file, close remote connection, that's how, that will actually kind of cleanly shut down the container, and it'll cleanly shut down the Jupyter Lab server that's running in there. So I'll just go ahead and shut down this one so I can start developing in a new container. That does mean that in my browser, the tab I had open to my Jupyter Lab is probably should be dead now. Yeah, so because the server has been stopped in the container underneath it, so I can't no longer do any stuff in that tab there. So yeah.
When I try accessing the classroom, the assignment 1, it gives me this.
Right, so it created your repository for you. So if you click on that link, that should take you to the repository that you can. So you can do the step that I'm about to show then. So once you get to your assignment 1 repository, we're going to clone the SSH URL at this point. Yeah. Sure, but yeah, it looks like it's working. So you did create the repository for you. So back to this. So I'll copy my SSH URL. I stopped my old container, so I'm just going to clone this new one. So we'll do the clone repository step again, paste it in. Again, select clone from URL. The clone from GitHub is slightly different kind of thing. You need to select the location to put it, so I'll put it again in my repos 574 subdirectory. So it'll create a directory called assignment1 dash, and then your GitHub username will be the name of the folder when it clones an assignment. So when it asks, you should always reopen the folder in VS Code. And this time, I got to keep moving this around here. I'm gonna take advantage of that, just because I want to do my development inside a container. So I'll just click that button to reopen in a new running container here. And again, this might take some time for you. For me, it won't take too long for me because again, I've already cached all of the images that Docker does, but it might need to start a new container and install Python and some other stuff in there. Although, yeah, I went over that step real quickly too. So. Okay, but anyways, yeah. So I'm now running my assignment 1 inside of my container again. So yeah.
Including the assignment, should I use the HTTP or?
You should use the SSH URL. So for the assignments, use the SSH URL. And I'm going to show in just a second here, that will give you the ability to create commits and then push them so I can see them and grade them. So again, yeah, if your SSH URL isn't working, that clone step wouldn't work here, okay? But it worked for me because I had my SSH key set up in my GitHub account. It was all working now. And again, we're running the same container setup, so if I open up a terminal, I'm actually inside of my container. I can actually run Python in here, 3.12. And we can import all the libraries like scikit-learn. And so on. It might be a good idea once you're in the container. Some people have problems. The key that you create is supposed to get injected or copied into the container. So you can test again inside of the terminal to see if you can authenticate. So you can do an SSH get at github.com. So even though we cloned successfully, the clone was happening on the host machine. But sometimes the keys don't get copied into the container. So if you can't authenticate in here, you might have problems. The easiest workaround that I suggest for people is you might have to generate a new key. So if you just generate a new key inside of the container, then you can copy that key again to your GitHub account and use a second key that's local to the container to do git clones and git pushes inside the container. But that's a good thing to try. So if people are having problems pushing commits back, I ask them to first try to authenticate again inside of the container and see if that's working or not. So again, we've got the Jupyter Lab server running. Right, so as it shows from this terminal output here. So I'll do the same thing I did before. I'll just go ahead and open up my nohup.out file and just control-click on that. So now I'm actually interacting with my Jupyter Lab server running on my assignment 1 container. Right? So for the assignments, there's normally going to be 2 things that you're going to be editing. So in the notebooks, there'll be a Python. You'll do a lot of your work in a notebook that's named something like assignment 1 something, or assignment 2, assignment 3 something. Right? So there'll be one notebook. This has all the instructions for what you're supposed to be doing on the assignment. Right? So you'll want to go there and read this to kind of get a description of what you're supposed to be doing. So for this assignment, there's 4 tasks. We have to write a Python function, a recursive Python function. Task 2, you'll be doing practicing doing some stuff with NumPy. Task 3, we'll write another function, a vectorized function. And there's some practice using matplotting on that one. And task 4 is a few tasks to do some stuff with the pandas library. So you'll also, for these assignments, you'll be writing some code. There's a source subdirectory that has an assignment task.py. You can open those and edit those inside of Jupyter Lab. Jupyter Lab doesn't have a really great editor, so I actually prefer, when I'm editing actual Python source files, is to edit those in VS Code. So you can also go to VS Code, go to the source subdirectory, and open up any of those, including like the assignment tasks here. So I'll just open up there. But yeah, I normally, if I want to edit actual Python code, I'd do it in personally, I prefer to do that in VS Code. But if I want to run notebook cells, I do that in my JupyterLab server in my browser on the system. So I jump back and forth between those. So I still got a little bit over 10 minutes. So for task 1, let me just show you a little bit. If you rerun, these notebooks should always run cleanly. So what I mean by that, if you're not familiar with Jupyter Notebooks, is this button here. If you do this to restart the kernel and rerun all the cells, you should find that when you start an assignment that all of these cells will actually run. Okay, so it ran these. Now some of these cells are doing what are known as tests. I want to show this. So some of these are running tests here. So in this notebook, these tests are actually passing. So all these tests passed on this first one. But there's a second one. I already modified this. Sorry. There's a second one that when you run it, these will be failing on here. And I'll show. And then our third test are testing some NumPy stuff. So notice these, you see kind of some error messages. The cell actually runs. It's just that it failed. It actually failed all of these tests for this task 2, the NumPy operation task. So, but the point I'm trying to make is that this notebook doesn't do a whole lot. Most of the cells are empty except for running these tests. But all these cells should run. So it should go all the way to the bottom, and every cell has a number beside it. So that means that every cell ran. It didn't stop in the middle with an error trying to run a cell. All these cells were attempted and ran. That should always be the starting state for your assignments. So I was going to show, I had actually forgotten, but let me remove. So when you start, your Fibonacci efficient is not going to have any implementation. So it'll just look like this. Auto return like 0 probably. So if I modify it, so I just modified this function in my assignment task called Fibonacci efficient, but I put it back to the way that you'll see it when you first start working on your assignment. It doesn't do it, it just returns 0 when this function is called. So if I rerun my notebook, rerun everything, it's still passing the first test, the test of the Fibonacci inefficient, but you'll find that it's failing all the tests for the function called the Fibonacci efficient function. Okay. So I want to show you making a commit. So I'm not going to actually give you the solution for the first task here, but basically the task 1, a Fibonacci number or the Fibonacci sequence, hopefully you're familiar, you've run across this before. So it's basically you get the next number in the sequence by adding the 2 previous. So by definition, we're calling the first and second Fibonacci number 1 and 2. So if you look at the inefficient version, this is a recursive implementation. It has 2 base cases. So if you ask for the first Fibonacci number, it returns 1. If you ask for the second Fibonacci number, it returns 2. And then if you ask for the third or further ones, it just calls itself recursively for the 2 previous and adds those together. So it adds 2 plus 1 to get 3 for the third one, and adds 2 plus 3 to get 5 for the fourth one in the sequence. 3 plus 5 is 8, and 5 plus 8 gives 13, and so on. So that's the definition of the Fibonacci sequence. So if you know anything about recursion, this is going to have an exponential explosion of recursive calls here. So if you try to calculate the 40th Fibonacci number or something, it'll take a long time. So this is an inefficient way to implement calculating the numbers in the Fibonacci sequence here. Okay. So you're supposed to, what you're actually doing for task 1 is you have to write an efficient version using memoization. And you can read this, or you can read that Python textbook that has a little section there about memoization. So basically, memoization is the idea that you have a cache. So we're going to use a dictionary. So anytime I calculate the 5th number in the Fibonacci sequence, if I have it in the dictionary or my cache, I just look it up and return that result. And if I don't have it, I have to do the calculation to get it. But once I do the calculation, I only do the calculation once, and then we put it in the dictionary. And that will give you a much more efficient implementation. Right? So just to show you doing a commit and pushing it, I'm going to cheat. So you wouldn't get any points if you did it like this, but I'm going to just copy the inefficient recursive implementation. That's what I had in there before. You can remove meta comments, like put your code here. So I implemented what's supposed to be the efficient version, but I'm still doing the same thing I did before. In fact, I'm going to modify this so it's actually recursively calling this new efficient version. So it's really not efficient. We're still doing the exponential recursive calls here. But it will work. So it is a correct implementation. So if I ask for these numbers, so it should pass the unit tests. So, so if I do that and save, the magic, this auto reload is a bit of magic that means that if you save the file, you don't have to go back and reload those functions from the assignment tasks. It will pick those up automatically. So my saving a new implementation of that, I don't have to rerun the cell to reload in the Fibonacci efficient. It automatically gets reloaded for me. So that means I can just, for example, I can just rerun these tests of the Fibonacci efficient, and they should pass now. Right? Because they weren't passing before, but now I gave an implementation of the Fibonacci efficient that is correct, so it returns the correct 37th Fibonacci number. It's just doing it in an inefficient way. Right? But this is good enough, so I can show you how to create a commit and push it. So to actually get your assignments graded, we need to get these back to your GitHub Classroom repository. So again, I recommend just using VS Code. So that's another thing you can do in VS Code. So if you look at your revision control, you should see that the notebook is modified, and also the assignment task should be not modified. It's not modified for me because I had done that before. So let me make another modification here. There we go. So this is probably what you'll see if you follow along with me. Right? So the source control is nice here. So you can do things like if I click on a file in the source control, I can get a side-by-side diff. So this is the only thing that's been modified in my assignment task so far is this line here. I modified that in order to get that, and like I said, that I had already done that before. So but that's the only modification, the only change I've made so far in this file was to add that so I can see a diff. Right? And you can actually see diffs in IPython notebooks. You didn't used to be able to do this, but if you click on the diffs here, it might be a little bit tough to read some of these, but you can get an idea that there's a difference between running the test cases in this cell in the notebook, although it was probably just the time, and a few other differences. Anyway, so to get this pushed back up so I can see it and grade it, you have to do these are normal Git stuff to create a commit. So you have to do what's known as staging the files for a commit. So I want to go ahead and stage both of these and make a commit of these. So I'm just going to add these individually, or I could add both of them at the same time. So you click on the plus to add individual files or all the files that have been modified. So I'm staging these to make a commit of these. Always give a good commit message that has a title. So a commit message has a title followed by a blank line followed by one or more sentences of description. So I won't give an example. I won't give an example of a good description, but try and give at least a sentence or two, and a separate thing that functions as a title for your commit messages. And try, I might make it a requirement. I want to see you incrementally working on the assignment. So give me a commit for every task for these assignments. So I shouldn't just have one commit at the end where you've done everything. So you should, once you finish task one, that's kind of a milestone. So you should make a commit of the work you did on task one once you get out working. At least you can have more than one commit for task one, showing incremental progress. But I would like to see at least a commit for each task for the assignments here. So once you do this and have a commit message, you can hit that check mark. This just creates a commit, but the commit is still only local. It hasn't actually been pushed. So if I looked at my repository on GitHub for the assignment one, I wouldn't see it yet. So if we looked at our poll, the place where I will see your commits when you push them is in these things called pull requests. There should always be a feedback pull request created for you. And every time I did some work on this last night for that video, but every time you push a commit, I will see this in your feedback pull request here. So, so to push a commit, you can hit the sync here. That will actually push it. You might, sometimes this button doesn't appear for some reason, I don't know why. So again, another good thing to know about is the status down here. This is giving you the status of your source control system. So this means, the 0 means that there's nothing on my GitHub repository that I haven't pulled down yet, but there is one commit locally that I created that hasn't been pushed back to the GitHub repository. Okay. So we can push it or sync it by hitting that, or you can actually push this down here to do the same thing, to push the commit. All right. So once you do that, you should see it. So there it was. This is the one I just did here in class, the second commit on my feedback pull request here. So you see it. So notice this is the title, and then you can expand or contract the longer description of the commit. And then importantly, the first thing I do when I'm grading students' work is I look at the workflow. So this is running those same tests that you run in your notebook. And it's creating the same environment. So it might take a little bit of time to do this. It has to actually install Python and create a container here on GitHub, but this is all happening on GitHub in the same Debian kind of container here. But once it gets the environment set up, it will run your notebook and it will run those tests in your notebook. It's a little bit tough to see here, but once it gets there, we'll see. So I should be passing my task 1 tests, and the notebook should be running cleanly, but the task 2, 3, 4 tests won't be passing yet because I haven't completed those. But it's a good idea every time you push to check this. So this will tell you if it might seem to be working locally on your system, but if it's not working here, you maybe have a mismatch on versions or some other issue like that, right? So you can always tell what I'm going to be seeing when I run your stuff by looking at the auto-grader workflow on GitHub. So here, it's running the test here. So the first thing it'll always do is it will test that your notebook actually runs all the cells from top to bottom. So that was what this first one here did. I really can't see it. And then it will run those same tests individually. So this is the task 1 tests here of the inefficient and the efficient version. And it's passing those, but it's failing task 2, 3, and 4 here. And we're getting a 30 out of 70 on the auto grader currently. So when you're done, if you get all the tasks to be passing, you'll get like a 70 out of 70 on the auto grader there. So, you won't necessarily get full points for the assignment if you get all the points in the auto grader, because I might take off points. Like, for example, I wouldn't give any points if your efficient version was just a copy of the inefficient version. So you wouldn't get those 10 points. You get those taken back off unless you implement it the right way. So, but this is a good kind of indication of how you're doing on the assignment. Okay, so yeah. it's 9:15. I'll go ahead and wrap it up there. So I've got 15 minutes till the next class. Let me know if I can look at anything. So yeah.
So what I was saying, my GitHub page, it says it's active, but
Right.
when it says you show, they didn't provide.
Yeah. So that's normal. So yeah, you can't secure shell in directly like this. But as long as you get the message that you're authenticated, you're good at that stuff. So you should be able to clone now in VS Code. Yeah. All right. Yep. That's it. So yeah, I'll stick around. If anybody has any questions? Question? No?